Hello, today we'll be discussing Python modules. So let's see what modules are and how we can use them. Modules refer to files containing Python statements and definition and code, and these have to be saved as a .py format. So if you're using Jupyter notebooks, you might be used to saving the notebook in the IPYNB format, but for a module to work, you have to store it as a .py. Now let's take a look at a little bit of code here. So for example, if I have this function called add, which takes in two numbers as arguments and then adds these numbers and returns the result. So this is a function that I have made, and I want to be able to use this function in different projects of mine that I work with. So to do that, I'll need to save it as a module, and to save it as a module, all I have to do is this bit of code in a separate file has to be named. So in this case, we're going to name it example, and we save it as example.py. So once we have saved it example.py, it becomes a module. It becomes a module that is available to me for use. Now, how do we import modules? In order to import modules, we have to use the keyword import, and when we say import followed by the module name, it gets imported directly into your workspace. So what that means is any code, any functions that you defined in that particular file called example are going to now be available to us. Now Python has a lot of modules available, so this can be quite tricky. There can be so many modules. In fact, we have modules that do the same thing, but different people have put them up. So it's quite a wide space over there. Let's see how we work with our particular module. So this is something we created, then we imported it into a different workbook maybe, and then how to use our add function. So you remember we had created this add function and put this in this example mod over here. So after importing, we can invoke it, call it using example.add. So now example is the name of the module which we have imported. We use the dot operator, and then we call the function and give it the arguments, and when we run it, this add module, this add function will be run, and the sum of 4 and 5.5 will be printed out. So we get 9.5 as an output for this thing. How can we import modules in another way? So let's say there's a module called math. It exists in Python for various mathematical functions, and it's got a number of interesting attributes that we can use. So the value of pi is stored in this module. So we can say import math and then print out the value of pi is math.py. So math.py here is telling Python that I want the value of pi, but I want it from the module called math. So in math, the module math, the value of pi is available as 3.1415 and so on. It's not the complete value of pi, but this is the representation of pi in the math module. Some other module might have a different representation. So the value of pi that you get is dependent upon the module that you are calling it to. We can also import modules with renaming. So instead of saying import math, we can say import math as m. So what this does is, whenever we need to invoke the dot operator, like we did here, math.py, we don't have to type math, we can just type m.py. This has two connotations here. It's advantageous because sometimes modules can be named rather extensively, so we can have really long names for those modules, and you don't want to use that long a name every time you are calling a function or a method. So that abbreviation of name is helpful. Also, many a times there are conventions. So for example, when you'll be learning machine learning, you'll be importing pandas as PD. So PD is the convention. It's important to know these conventions also, because a lot of programmers will be having code which is written using the convention as a shortened form. So if you try to run a code with a different short form, then the whole code might have to be rewritten, or at least you might have to re-import it as a convention. So one of the two. So it's important to understand how this renaming works and why it's important. Okay. Now you may not want to use everything from a module. You may only want to use a particular function or a particular set of functions. So in that case, it's not a good idea to import the whole module. Instead of that, what you can do is you can say from math import pi. What this does is, it does not import math. It only imports the pi. But here we are telling Python that I want pi from the math module. So I've got a function only or an attribute only from the math module. Now when I want to use the value of pi, I do not have to use the dot operator. I can just write pi, because pi itself has been imported. Math has not been imported. In fact, if I write math.py, it's going to throw me an error because Python will not recognize math since I have not imported it. So this works. Next, we can also import multiples. So we can import pi.e and we get the values for pi and e. That's fine. And we can import everything also. Now this is an interesting situation. Take a look. So if we want to import everything from a module, we can just say from math.import. And then we say print the value of pi is pi, because we know that pi is a part of this math module. So we don't have to specify individually which functions or attributes we want. Doing this helps us to avoid writing the prefix. So we don't have to write math.py. We can just write pi. However, it is not a good practice, because what it does is it's getting everything in. We don't even know what functions are being brought in, and we are letting go of the advantage of namespace that we have when we import math. So had we just said import math, we would have had to write math.py, which would have been a good thing, because then it would have told us that this pi is coming from math. Now suppose you have imported two functions. One could be from math import everything, and another could be from, say, stats import everything. Now these two functions may have different values of pi. These two modules may have different values of pi stored in them. So when the first time from math you import everything, you got a particular value of pi. Then from stats you again imported pi. So the first value of pi got overrun. So then now you are in a position you don't really know which pi is working. And this can get complicated very soon if you are importing a number of modules. So from a module, importing an asterisk it works, but it is not a recommended practice. This thing is not a good idea. So let's try and avoid this thing. Now there's something called the search path, and what we are doing here is that when you are importing a module, you have to tell Python where to look for that module. So the Python interpreter will first look for a built-in module. That's the first thing it will try to look at. If it doesn't find it, then it has to look into a directories list. Now this list of directories is stored in a path. It's called the Python environment path or the sys path, and you can look for it. You can import sys and then print out the sys.path. So this is what it tells you. It's a list of all the possible places where Python can look for the module that you're trying to import. If it's not there, you can add and modify to this list, and you can add your own path. So that can work around if you have an issue with locating the module. Once you have loaded a module into a workflow and you start working it, you have to remember that Python will load a module only once. The interpreter, it's going to only go once into this location and pick out the file that you want. So if you are running a session and then you want to reload it, you have two options. So reloading a module, one way could be you stop the kernel, you restart it and you reload it. But this is not very efficient. It gets rid of all the variables and all the work you've done in the past in that session. A more efficient way is to use something called the imp module. So you have to import that module, import imp, and then once you have imported it, you call the reload method. So you say imp.reload my module. This is how it works. First you import imp and then you import reload my module. So this works. This is very, very efficient because the variables you have stored earlier, the work you have done already, any kind of printouts or any models that you have built which might have taken a bit of time, they are still with you, and all you're doing is just reloading the code from that particular module. That's it. Finally, we come to the directory function, and the directory function can be used to find out the names that are defined within a module. So just a quick reckoner. You can use directory parenthesis and then pass the name of the module, and it will bring out all the names that are there within that particular module. Now if you remember the function add in the first module we built today, in the example module we had a function that added 2 numbers. So if you run directory, it's going to throw up all the hidden functions also. These are the ones that are part of that module which were not specifically designed by us or told by us to Python, because they exist as already there. However, look at the last one here. So this last one is the function that you had defined in the example module, and it shows up here when we are running this command directory and we are passing it the module example. So that's it for modules. I hope you enjoyed the session. See you in the next one.